Okay, so this first video, since it was shorter, it's not going to be like the other videos, but it still will cover what we need to cover. I will explain each step that I have in these problems. So here we go. First off, we're going to learn how an equation works. And so, like I was telling you before, an equation is a math sentence that shows two values are equal. We have to keep this true. Okay? For example, if I were to take away 3, I have to take it away on the other side as well. Why? Because I need to keep this statement true. So if I take it away on one side, I get x equals 3. Why is it still true? Well, I'm keeping it what they say is balanced. Alright? If I have a trash bag, okay, if I have a trash bag and I have another trash bag and this trash has 2 layers and this trash has 2 layers, well, if I take away a layer on this trash bag and I need to make it equal to the other one, I have to take out a layer of the other one. All we do, that's why I have to do things on both sides. Okay? Whatever I do to one side, I have to do the other to make sure that it stays equal. Alright? Now, to solve an equation is to get a variable by itself. That's the whole idea that I'm saying is I want to get x by itself. This wants to be single. It doesn't want to have the 3. It doesn't want to be tied down. So the word or the way we say it is isolate. Isolated means you're by yourself. You're alone. You're all alone. You're isolated. Oh my gosh, I'm by myself. Oh, I'm all by myself. Okay? That is what isolated means. It says we must get rid of every number that is close to a variable. See? Get rid of everything that is close to the variable. How do we do that? To do this, we are going to use inverse operations. Or in layman's terms, something that's very basic, okay, is we just do the opposite. Alright? So let's take a look at it. Solving a one-step equation. You're going to simplify each side of the equation, use distributive property, combine like terms, cancel fractions, get all variables on the same side. That's a lot of work, but what they're saying is, for example, if I have 2 parentheses x plus 7 equals, let's say 20, okay? What ends up happening is I have to simplify first. I have to distribute this out. Now, a lot of you on the test messed up with distributive property. That was your weakness. I want you to see it as duck, duck, goose, okay? If I undo this, it just is the 2 is on the outside, and instead of saying duck, duck, it goes multiply, multiply. So when I do that, I get 2x plus 2 times 7 is 14 equals 20. Now I have an equation. Now I have to do what I need to do. Now it's simplified, and now I can just try and get the x by itself and for it to become single. And what this section is we're going to learn what are the steps to make it single. Okay? Also, what it says here is eliminate the constant on the same side of the variable. Eliminate the constant. What's a constant? Okay? What the heck is a constant? Well, let me show you real quick. A constant is the one that doesn't have a variable in it. The one that's usually with the plus or with the minus, it's just separated. It's its own thing. It's the one that can't change. 14 is never going to change. Why? Well, because it doesn't have a variable next to it. The 2 is going to change because it's 2 times x. 14 can't change. It's going to always be 14. Alright, so they're saying we have to get rid of our constant first. Do we have to? Technically no, but that's the best way to do it. How would I do that? I'd subtract 14, but whatever I do on one side, I do to the other. Now it's gone, and I get 2x equals 6. Okay? That's what they mean by constant. Okay? Now, let's move forward. Now we're actually going to solve some. So in this problem right here, if you take a look, I already have the steps there, so I'm going to point some out. Originally, the problem is 8 plus x equals 14. So what I do for the first step, well, my goal is to get what? I want to get x by itself. I want it to be single. It wants to be alone. It wants to be isolated. Who's in the way? Who does not want to leave? It's like, no, no, don't leave me. Is the 8. Now, how do I get rid of the 8? Well, this is technically a positive 8. The opposite of positive 8 is, you bet, negative 8. So I'm going to take it away. But if I take it away on one side, I have to stay balanced to keep the statement true. I have to take it away on the other side. And now I'm left with x equals 14 minus 8 is 6. Okay, look at this one again. Right here, I have original problem is negative 6 plus x equals 4. Well, how am I going to solve that? Well, what I have to do again is I have to do the opposite. X wants to be by itself. Who's in the way? Negative 6 is in the way. What's the opposite of negative 6? There it is. I'm going to add 6. But if I add 6 to one side, I got to add 6 to the other side. Now these cancel, and I'm left with x is by itself and equals, what's 4 plus 6? Is 10. Okay. I can go back and check it. Negative 6 plus, now it's a 10 because it's not an x anymore. We substitute it. Equals 4. Does that work? Yes. Negative 6 plus 10 is short. 4 equals 4. It is a true statement. We are all good. Alright. I'm going to do one more. And then if you want, you could try number 4. Number 3 is same thing. Original problem is b plus 6 equals negative 11. And you're going to say, okay, well, b wants to be by itself. It wants to be single. The 6 is in the way. What's the opposite of positive 6? Well, the opposite is negative 6 right here. So what I'm going to do is I'm going to take away the 6, but if I take away the 6 on one side, okay, I have to take away the 6 on the other side to keep everything balanced. Now, don't be too crazy. So don't get scared with the negatives. All it is negative 11 plus negative 6 is negative 17, and now I have b by itself, and I'm all good. I know what b is now. Now it's negative 17 plus 6 equals negative 11. I substituted, and does that work? Yes, I get negative 11 equals negative 11. It is still a true statement, and now I know what b actually is alone. Now it discovered itself. It's like, man, when I'm single, I know who I am. I'm a negative 11. I'm a negative 17. Okay? So, what happens, though, for equations that have, like, parentheses or things like that? Let's go with number 6. All right, now I have more things, right? I have some work to do. Well, what ends up happening on this one, see the left side? I just simplify that. 10 minus 7 becomes a 3. All right, so they write 3. Notice they drop down the equals, so I still have equals. All right, x, and then the 12. It's like, oh my gosh. The x is so tired, it's like, 12, get out of here. I don't want you here. I want to be single. Okay? I want to be single. So the opposite of positive 12 would be you got it, a negative 12. But if I subtract 12 on this side, I have to subtract 12 on this side to stay even. So I get 3 plus a negative 12, which is negative 9, right there. So I know when x is single, it is a negative 9. All right? You have to simplify now both sides. Now, let's check number 8. So look at this one. This one right here, my goal is to simplify both sides, this side and this side. So x plus 15, there's nothing to do yet. All we know is that the 15 is in the way. It's like, ugh, dude, like, get away from me. I'm just trying to be single over here. But before we can move, we have to simplify all this. So here's what gets tricky. We're going to have to use distributive property. Or you have to still do the parentheses, right? PEMDAS. So in the parentheses, I have negative 3 minus 7. Or negative 3 plus a negative 7. So if I am down $3 and I lose $7, I'm going to be down 10. That's why this is a negative 10 right here. But now it's 20 minus a minus 10. That means not. A minus makes it a positive. Okay? So now I have 20 plus 10, which becomes 30. Okay. So now what ends up happening here is I look at now the 15. The 15 is like, dude, you got to go. The opposite of positive 15 is subtract 15. So once I subtract 15, it's like, ba-ba-da-ba, you are gone. But I have to do it to the other side. And 30 plus negative 15 or 30 minus 15 is 15. All right. Now, these aren't too bad. If you try number 5 and 7 or take a look at it, if you have questions, ask me about number 5, ask me about number 7, take a look at it. See if you could do it by yourself. All right. Now, these right here, same thing. It's nothing different. All we're saying here is I have a, let's say number 10 is negative 5 plus y equals 15. That's, oh, that doesn't look like a 15. Okay. All they're saying here is, hey, I have to solve. I have to be single. Okay. The opposite of negative 5 is positive 5. Positive 5. And that's what they do. Bam, cancel. Bam, cancel. Oh, not cancel. Sorry, add. And I get y equals 20. That's all we're doing. We're just doing the opposite. Okay. Now, here's where it gets kind of tricky. Again, this one right here is the original problem is x over 9. Oh, let me write it above. The original problem for number 11 is x over 9 equals 10. And our goal is to get x single, right? So who's in the way? The 9. And what is the 9 doing to the x? It's like, dude, get away, like stop. And it's like, oh no, like I'm still here. Well, it's over 9. When that happens, that little fraction means that the 9 is getting divided. So the opposite of dividing by 9 is multiplying by 9. But if I multiply by 9 on this side, I have to multiply by 9 on this side. So here's what happens. They cancel. Why do they cancel though? Technically, when I multiply straight across. So I get 9x over 1. Over 9 equals 90. Okay? And now what happens is it's like, wait, the x isn't by itself. Yes, it is. Because what's 9 divided by 9 is 1x. So I get 1x equals 90. Okay? Now, some of you are going to be like, that's kind of weird. So here's how the book says it. The book says the easiest way to do it is to just flip it. Whenever you have a fraction, multiply it by flipping. And multiplying by flipping means we're just doing the opposite. So for example, this one right here is negative 1 over 5, b equals negative 12. All right. Who's in the way? Well, the negative 1/5 is in the way. So the opposite of that, instead of dividing by 5, I what? Multiply by 5. Instead of the top part is multiplying. Or I just flip it. Instead of multiplying by 5, etc., I'm going to flip 5 and negative 1. So I flip this so it cancels, but I have to keep everything even. So now it's 5 goes on top, negative 1 goes on bottom. And now I can multiply. Negative 12 times 5 is negative 60 over negative 1, which equals 60. So b equals 60. Now, let me do another one. All right? Don't get too, well, not do another one, but don't get too scared about those problems. So let me go back to, let me erase it all. All right? And let's go back to this one. So, this one right here, I said the opposite of dividing 9 is multiplying by 9, which is what we did. But let's go with that whole flipping concept. If I have x over 9 equals 10, okay, technically this is a 1x. So I technically have 1 over 9x equals 10. So in order to get rid of this part right here, I multiply it by the reciprocal, the flip version. So I'm going to multiply by 9 over 1 and multiply by 9 over 1. And I end up what? The cancel. So I'm left with x equals 10 times 9 is 90 over 1, which equals 90. All you have to do to get rid of a fraction is multiply by the flip. Now remember, fractions, like if I have 1 over 2 times 3 over 4, you multiply fractions straight across, which is 3 over 8. Fractions are multiplied straight across. Now if you notice right here, I do have an equation that's in words. Okay, I want you to take a look at these examples. Just take a look at them. All it is it's solving for variables, but in a different way. It's using it as a word problem. You might see that in your homework. All right? Don't worry too much about that. I want you to focus on these right here. I want you to look at those right there. Now, once you're done looking at this video, I want you to take out your homework, all right? And it is 2.2 that's due Thursday. So your homework, all right? Don't worry about this. This is something else. This is a different one. This is a slideshow that I borrowed. All right. Well, problems that I borrowed. I don't want these as classwork. Homework due Thursday. And what you're going to work on right now is page 86, and it's 1 through 41 odd. So after you're done with this video, you still can listen to it, do what you got to do, but you have to work on your work. If you want to listen to it as you're working on it and double check, you can. No talking, etc. If you whisper to your partner, all right, maybe you can work on it together. If you're under control, I will allow that. If not, you raise your hand and ask me questions. Raise your hand at any time if you have a question, even during the video. Thank you.